In this video, we'll explain the trigonometric ratio and we will explain how finding the sixth trigonometric ratio and how using that trigonometric ratio to solve. What is the trigonometric ratio? Is a branch of mathematics that deals with the sides and angles of right angle triangle. Therefore, the trigonometric ratio, are evaluated with respect to sides and angles. For a triangle ABC, which has right angle in C, and there's two acute angle A and B, the sixth trigonometric ratio are sine and cosine and tan, and we have cosec and secant and cotan. But the main question is, how can I find these six trigonometry? For right angle triangle, for example, ABC, which has right angle in C, and two acute angles A and B. Okay, before finding the sixth trigonometric ratio, you have to know where's the three sides adjacent and the opposite and the hypotenuse. Okay, it's easy because for any acute angles, for example, here angle B, for any acute angle, there is two sides, okay? Long side and short side. The short side of the angle is the adjacent, and the long side is the hypotenuse. So the third side, it will be the opposite. This is how to know where is the opposite and the adjacent and the hypotenuse. So to find the sine of angle B, for example, it's the opposite over the hypotenuse. The cosine of the angle is the adjacent over hypotenuse, and the tan of the angle is the opposite over adjacent. What about the other angle? For the other angle, since this is the sides of the angle, so this is the adjacent now, and this is the opposite, because the adjacent is the side of the angle. And we will use the same formula to find the three trigonometric ratio. If you want to memorize the formula of the three trigonometric ratio, use these three words. So, S means sine, and O being opposite, and H mean hypotenuse, and K for cosine, adjacent and hypotenuse, and Twa, tan, opposite and adjacent. Okay, so this is how to memorize the three trigonometric ratio. What about the other three trigonometric ratio, cosec and secant and cotan? Actually, it's the reciprocal of these three trigonometric ratio. So the cosec of the angle is the reciprocal of the sine, so it is the hypotenuse over opposite, and the secant is the reciprocal of cosine, so it is hypotenuse over adjacent, and the cotan is the reciprocal of tan, so it is the adjacent over opposite. Look to this example. I have this triangle EFG, which has right angle in F. Okay, and side EG is 5 centimeter, and side EF is 4 centimeter, and side FG is 3 centimeter. I want to find the sixth trigonometric ratio of angle G here. This is angle G, and this is the sides of angle G. So the short side is the adjacent, which is 3 centimeter, and the long side is the hypotenuse. So the third side, it will be the opposite. Now, after know where's the opposite and the adjacent and hypotenuse, based on the formula of the sixth trigonometric ratio, it's easy now by substituting the formula to find the sixth trigonometric ratio. So the sine is 4 over 5 of angle G. And direct, you can find the cosec by flipping the sign. So the cosec is 5 over 4. The cosine, since it's adjacent over hypotenuse, 3 over 5. And direct, you can find the secant by flipping the cosine, 5 over 3. And the tan, opposite over adjacent, 4 over 3. Direct, you can find the cotan by flipping the tan, which is 3 over 4. So this is how finding the sixth trigonometric ratio. But the question is now, how can I use it to find the missing sides and angles in the right angle triangle? Okay, so look to this example. The example is solve the given triangle. The triangle is EFG, which has right angle in F. And the side EF is 6 centimeter, and the measure of angle E is 60 degree. Now, I will use this information to solve this triangle, mean that I will find the side of G and side EG and the measure of angle G. I will start now to find the measure of angle G, since the acute angles of any right angle triangle are complementary. The meaning of complementary that the sum of its measure equal 90 degrees. This is always for any right angle triangle. So it's easy to find the measure of the other angle by subtracting the given angle from 90 degrees. So 60, I will subtract it from 90, so the measure of angle G is 30 degree. So after now I found the measure of angle G, I will find the other unknown sides. I will represent each side by X and Y. But before that, I will know I have to know where is the opposite and the adjacent, the hypotenuse. This is angle E, and this is the sides of angle E. So this is the hypotenuse and this is the adjacent. So the third side is the opposite. Now I will represent the long side by x, which is the hypotenuse, and the opposite side by y. Now I will start to find the side x. Since the given side is adjacent, and I will use direct the cosine, since the cosine contains the adjacent of the hypotenuse. By substituting the formula, cosine 60 is 6 over x. Since the unknown is down, so mean that divide. So x equals 6 over cosine 60. So the answer is 12. Mean that the sides is 12 centimeter. Now the turn to find y. Now for y, it's up to you to use the tan or the sine, since you have the adjacent and you have the hypotenuse. So it's up to you. I will use the sine. So sine E is opposite over hypotenuse. Substitute the formula. Sine 60 is y over 12. Since the unknown now is up, so mean that multiply. Y equal 12 times sine 60. So it is 6 square root of 3, mean that the length of side FG is 6 square root of 3 centimeter. Now, how can I use the sixth trigonometric ratio to find the angles, the missing angles? Look to this example. Find the value of x. This is the triangle, right angle triangle, and the given sides 7 and 14, and the angle G is represented by x. Now, I will use the trigonometric ratio to evaluate and find the measure of this angle. Now, before that, I have to know where is the adjacent and the opposite and the hypotenuse. This is the sides of angle G. So I mean that this is the adjacent, this is the hypotenuse, and this is the opposite. Now I will use the tan. Why? Because the given sides is the opposite and the adjacent. So I have to use the formula of tan since it's contained the opposite and the adjacent. By substituting the formula, tan x equals 7 over 14. If you want to find the measure of the angle, use the inverse of the trigonometric ratio. So by taking tan inverse for both sides, I will have x equal 26.6 degree. So I mean that the measure of this angle is 26.6 degree. And this angle E, since it's complementary with angle G, I will find it direct 63.4 by subtracting 26.6 from 90. Okay, so for any right angle triangle, ABC, for angle B, this is the opposite, this is the hypotenuse, this is the adjacent, and for angle A, I will have to switch the opposite and the adjacent. And I will use X and Y and H here to represent the sides. So, and to memorize the formula, I will use these three words, soh and kah and twa. This is the formula of the sixth trigonometric ratio of angle B, and this is for angle A. But look here, since angle A and angle B, the complementary angles of right angle triangle, you can see that the sine of angle A is the same as cosine of angle B. So it's equal. The same for cosine of angle A and sine of angle B. And tan of angle A is same as cotan of angle B, so it's equal. And here we have tan of angle B, same as cotan of angle A, and the same for secant of angle A is cosecant of angle B, and the same for secant B is cosec of angle A. So this has happened if A and B are two complementary angles, we can have this relation. This is everything about sine and cosine and tan, how to find it, how to use it to solve the triangle. Thank you for watching us. See you next video, inshallah.